All right, so the big idea for sequences is we want to know, does this list of numbers, if we write out an infinitely long list of numbers, do the numbers in this list appear to be getting closer to a particular number, a very specific number? This is what it means to converge. So if we have a list of numbers and they are all getting closer and closer and closer to this one specific real number, then we would say that the sequence converges to that specific real number. But if a sequence, no matter how far down the list you look, it doesn't look like the sequence is actually getting closer to any specific real number, it kind of bounces around, and there's no discernible pattern, then we would say that the sequence diverges. So example 2, we can investigate this idea of convergence. So here we have two distinct sequences. We've got a sub n, which the general term is given by 1 over n, and b sub n, which is given by n. So what I'm going to do here is I'm going to list out, excuse me, a table. Oops, let's do this in black. List out a table. So I'm going to have a column for n, and then I'm going to have a column for a sub n and b sub n. So remember, a sub n is 1 over n, and b sub n is just equal to n. So when n is, well, can n be 0? Not for this sequence, so I'm just going to say undefined for this one, but here we get 0. And then for 1, we have 1 over 1, so 1 and 1. For n equals 2, we have a half, and we have 2. And it doesn't take too many numbers to fill out to understand what's going to happen here. So let's just go the first 5 terms. So here we've got 1/3, 1/4, 1/5, and here we have 3, 4, and 5. So if we were to actually get a decimal expansion for each of these numbers, so figure out what the decimal is, and it doesn't matter where we round, but let's say we write out, a couple decimal places, and we just look to see what the decimals are doing. Well, what happens here is we have 1, 0.5, 0.3 repeating, 0.25, 0.2, and we keep going. And if we would keep going down this list, so let's say here, maybe I want to skip a few, and here we could take a look at, let's say, 100. Then this would be 1/100th, and our decimal expansion would be 0.01. And this decimal expansion would be, well, just 100. So you can see that these numbers here in this sequence of b sub n, these numbers are just climbing and getting bigger. As n gets larger, so does b sub n. And since there's no bound to n can get as large as it wants to. It can continue towards infinity, so will our sequence of b sub n. It will continue to grow without bound, diverging to infinity. Whereas the sequence of a sub n, these numbers are not getting bigger and bigger and bigger without bound. In fact, in this case, it's decreasing, so the numbers are getting smaller, but they're not getting smaller without bound either, right? This isn't plunging down to negative infinity. This is decreasing because these decimals are getting smaller each time when we move farther down the list in the sequence. But what is happening is our decimal expansions, all these numbers are getting closer and closer to a specific real number, 0. So in this case, we would say there's two things. For the sequence of a sub n, we would say a sub n converges to that specific real number. You can sort of think of this list of numbers as honing in on a specific real number, as if we were approaching it. Down here, we would say that the sequence of b sub n diverges. And now there's different ways that a sequence can diverge, but one of the ways that a sequence diverges is that it just grows or decreases. It increases or decreases without bound. So if something is increasing without bound, that means it's going to approach infinity, positive infinity. If something decreases without bound, that means that eventually, even if it begins as a positive quantity, if it decreases without bound, it will hit zero and then decrease from zero and then continue decreasing indefinitely, so that we would say that the sequence diverges to negative infinity. But there is another way a sequence can diverge, and that would be the sequence doesn't just, maybe it doesn't increase or decrease forever. Maybe it oscillates, sort of like the graph of sine or cosine. It never hones in on one specific number. It's just always winding back and forth, up and down, up and down. It's never settling on a specific real number. So in this case, we can say a little bit more than just diverges. We can actually be more specific, and we can say that this sequence diverges to infinity. It just provides a little bit more context and information to the reader, in which case it's useful to do so. But technically, even if you said that the sequence diverges, that is true. But generally speaking, you want to provide more information, not just that the sequence diverges, but why is it divergent?